Okay, let's get started with section R7, and we're going to split this into two pieces. So this will be R7A, and we'll follow it up tomorrow, next class, with R7B. So to help us with some of our graphing polynomials, which will come in chapter 5 here, we need to go back and review rational expressions. So we're going to do the first three objectives here in R7A. We'll do objectives 4 and 5 in R7B. So objective 1, reduce a rational expression to lowest terms. So we're going to factor as much as we can and cancel. Let me actually back up one step here. A couple things to put down in your notes just as review. X squared minus a squared factors out to x plus a and x minus a. If we have a minus x, you can always flip that around and get negative x minus a. So if for some reason you wanted to switch the order, just bring that negative out front. And then we do have our cubing factorization. So x cubed plus a cubed factors down to x plus a. X squared minus ax plus a squared. And then the reverse, if we have x cubed minus a cubed, we have x minus a, and then x squared plus ax plus a squared. So this and this sign will always be the opposite, and this leading sign will be the same as what's in the problem. All right, so make sure you have those, and we'll take a look at a couple problems here. So this first one's fairly straightforward. Factor, factor, factor. We're going to have some practice doing that. So the numerator here factors to x plus 2 and x plus 3. And our denominator factors to x plus 2 and x minus 1. And so we can cancel here, and so when we've reduced to final terms, the lowest terms, we have x plus 3 over x minus 1. We do want to put our restrictions. X cannot equal 1. It can also not equal negative 2. Because even though I've canceled it away, if I took negative 2 and plugged it back in here, negative 2 squared is 4, plus negative 2 minus 2, that turns into 4 minus 4, and I get 0 in the denominator, even though we've canceled this term out. So make sure you get all possible restrictions in there. Let's take a look at a couple more here. Reduce each rational expression to lowest terms. So cubic factorization here is going to be x plus 1, x squared minus x plus 1, over, and we can pull an x out front here, and then we'd have x squared. I'm sorry, we can pull an x squared out. X plus 1. And let's go ahead and cancel. So we'll have x squared minus x plus 1. Nothing left to factor there over x squared. And our restriction, x cannot equal 0. And it cannot equal negative 1. Second one here, let's reverse this. Negative x minus 2 over x minus 2, x plus 2. X minus 2's cancel. We're left with negative 1 over x plus 2. X cannot be plus or minus 2 because of the positive 2 there. All right, try problem 5. Second objective, let's multiply and divide. So remember, if you multiply straight across. A times C to get AC, B times D to get BD. Remember that B and D cannot be 0 here. And instead of dividing fractions, we're going to multiply by the reciprocal. We've done that before. And in this case, you can't have a 0 anywhere in the denominator. So B can't be 0, D can't be 0, and because this will eventually flip over, C can't be 0. A is the only thing that could be 0 in this whole problem. Okay, so let's try this. So let's simplify first, and then we'll cancel. So 4. X plus 9, and then this is x plus 9, x minus 9. And then we've got x minus 9 and an x plus 2. And we've got an x, let's see here, minus 3 and an x plus 2. And so let's cancel where we can. An x minus 9 will cancel, and so we'll have 4 x plus 9 squared all over x minus 3, x plus 2 squared. Restrictions, x cannot equal 9, -2, or 3. All right? So every single piece here has to be in the restriction. Let's check this one out here. So factor first. This is going to be x plus 3x minus 3 over 4 times, and let's flip this over. So this piece first. This is going to be x minus 3, x plus 2 over, factor this here, this is going to be x minus 3, x minus 3. And so we get to cancel here, and we get to cancel here. And so we have x plus 3 times x plus 2 all over 4. And we do have some restrictions here. X cannot equal. Now, here's where it's a little tricky. We know that 4 can't be 0, but it can't. We know that the zeros from here don't work. So that's going to be the 3 and the -2. And these numbers here also could not be 0, because then you'd be dividing by 0 as well. So that's also 3. Luckily, we already have it here. But you want to look everywhere you can for restrictions. All right, try 17 and 25. All right, last objective here. We're going to add and subtract rational expressions. If we have a common denominator, we're in good shape. We can just add the numerators or subtract. So we'll start with that. Nice, easy peasy ones where we have common denominators. This is 3x squared plus x plus 4 all over 2x minus 1. And you want to check to see if you can factor this. Here, AC would be 12, and B is 1. There's no way to multiply to 12 and add to 1, so our job here is done. All right. And then on the next one here, we're going to have 3x minus 5x is -2x minus 4. Be careful here, that negative is going to distribute all over x plus 3. We do want to leave this in factored form, and we can factor out a -2 here, which becomes an x plus 2 once we pull that -2 out, all over x plus 3. And they already told us here our restriction is not, x cannot equal -3. All right. What about something like this? This looks like we don't have a common denominator, but we really do. If we switch this one around, we could multiply top and bottom by -1 and have -4x over x minus 2 plus 2 over x minus 2. And then we've got -4x plus 2 all over x minus 2. And we can factor here, pull out a -2, and you're left with 2x minus 1 all over x minus 2. We know that x cannot equal 2. All right, try 37 and 43. All right, last section here. What do we do if we add or subtract without the common denominator? We need to get a common denominator. So we need to, if we're doing AB plus CD, multiply here by D over D, and multiply here by B over B to get your common denominator. All right, so problem A here, we need to multiply top and bottom by an x plus 1 over an x plus 1. And the second fraction, we need to multiply top and bottom by x minus 4. So we'll end up with x squared plus 3x plus 2 plus 3x squared minus 12x. And I'm going to come back to the denominator once we clean this up. So let's put these together. This is 4x squared, and then we've got minus 9x plus 2. And so in this case, AC is 8 and B is -9. So this is going to work. So this is going to be -8 and -1 over our A. And so that's a -2 and a 1 and a -1 and a 4. So here we are in business. We've got x minus 2, and we've got 4x minus 1. All right, so we've completely factored the numerator. This is all over x minus 4, x plus 1. X cannot equal 4 or -1. All right, so that would be your answer. All right, if you need to get that down, pause it for a second because I'm going to clear the screen off here. All Alright, now let's try B. So on B here, before we do anything, it might be helpful here to rewrite this as x plus 2, x plus 1. Okay, so it might help us, we might have to go backwards, but factoring first is usually pretty helpful. So we're going to multiply this fraction by x plus 2 and x plus 1, sorry. Top and bottom. And this fraction over here needs to be multiplied by 2x over 2x. So we're going to have x plus 2, x plus 1, minus 2x times x, which is 2x squared. And let's clean this up first. So we know that this is actually x squared plus 3x plus 2 minus 2x squared. So we've got negative x squared plus 3x plus 2, right? 1x squared minus 2x squared gives you a negative x squared. All over 2x, x plus 2, and x plus 1. Does the numerator factor at all? AC would be negative 2, and B is 3. No way to multiply to negative 2 and add to 3. So our job here is done. Let's get the restrictions. X does not equal 0, negative 2, or negative 1. All right, try problem 47. And that will do it for R7A. Any questions, make sure you get them answered in class. Good luck with those problems.